Good morning, my name is Darwin Vásquez. I am petroleum engineer student at the Sur Colombiana University. Today I will tell you about my degree project called Determination of the Molar Mass of Crudes by Bycryoscopy. The goal of this work was to develop an experimental and accessible method to find the molar mass at the university. The contents of the presentation are: first, introduction; second, conceptual framework; third, materials and methods; fourth, results and analysis; fifth, conclusion and recommendation. Molar mass isn't a commercial reference as API gravity, still important as indicative of size and molecular structure. It's relevant in the processes of production, characterization, and simulation. When the molar mass of oil is needed, empirical methods or correlation are generally used, but experimental methods to find it are unknown. The colligative properties depend on the number of particles and not by nature of the solute. Are consequence of the reduction of the solvent chemical potential and are more notorious with increased the solute concentration. The first property is the decrease in vapor pressure. The laws of Rao and Dalton describe behavior for ideal mixture, such as benzene and toluene. As toluene is added to vapor pressure decrease under a straight line behavior, as you see here. The second and third properties are boiling point increase and freezing point decrease. This is the pressure temperature diagram for a pure solvent. When you add a solute, the behavior changes in melting point and boiling point. The changes are proportional to a constant and solution concentration. The CRYOSCOPY constant depends only pure solvent and is calculated with this relationship that you see here. Solid concentration is in terms of molality. Adding other concepts like molar mass and density, you can get this relationship. This relationship is to calculate the molar mass of crude by as a function of the variation in melting point of the solvent. The fourth property is osmotic pressure. In this system, we have solvent and solution separated by a membrane. Due to the energy difference between the two substances, the solvent passes through the membrane, generating a hydrostatic column that in terms of pressure is known as osmotic pressure. To determine the molar mass of oil, empirical methods are mainly used, such as the molar average. Empirical methods were performed with experimental data from theoretical assumption or bit of both. Experimental methods as vapor pressure osmometry, cryoscopy, gel permeation chromatography. There are three standardized ESTM procedures for crudes and oil products, two for estimate and one for interior measurement. For the materials, I used three solvents. The temperature bath was glycol and distilled water. The tests were developed with two medium crudes of 30.5 and 23.2. The density were measured in the laboratory. The solubility parameters present here are from correlations. The solubility parameter is a scale that indicates the level of adherence between molecules, and it's useful to find the solvency or affinity between substances. According to Burke, the solvent solution involves many factors, such as evaporation rate, solution viscosity, environmental and health risk, affinity to properly dissolve a material without affecting other. The component intermolecular force should be similar between solute and solvent. Dos Santos considered that there are two important aspects. Solvents with high molar mass have fewer particles in a given volume for interaction with the solute, and drastic melting temperature can generate losses by volatility or operational rates or need throws measuring equipment. Under the previous consideration, I made a series of filters to get three solvents from a list of 911. Initially, the solvents were taken with a melting point between 1 and 15 degrees Celsius. I shared the fusion enthalpy through the cast number with in Denise and in Chemeo, considering properties measured. Solubility parameters were charged to identify the affinity between oil and solvents, considering a range between 12 and 20. Solvents with a cryoscopic constant greater than 4 degrees Kelvin per mole were preselected. At this point, the list was air solvent. Finally, cyclohexane, benzene, and oleic acid were chosen for the ease of obtaining them. This is the list of air solvents that passed the filters. Those ingredients were chosen to develop the test. To the assembly, initially I developed a peltier cells cooling system which didn't reach temperatures below 6 degrees Celsius. So I carry out some tests with the pure solvent in a thermocrystal. This equipment is used to find the flow points. I use centrifugal tubes to introduce the samples of the 10 milliliters into the vat. The system for measuring the temperature was the same in all assemblies, as you see here. Later, I made improvements to the assembly, adding a stirrer to blend, decrease the sample volume to 3 milliliters, and discarded oleic acid due to its low purity. Subsequently, I decreased the volume of the temperature vat to control the cooling rate a little better, and changed the sample container for the test tube. This is the diagram for the final assembly. I must emphasize that you use accessible elements. For the cryoscopic protocol, first cool the temperature back to the below minus 4 degrees Celsius. Next, prepare the sample in a test tube. Place the sample in the bath, checking the sample continuously at variable speed until the solidification. Record and plot the temperature logs on a semi-logarithmic scale. The melting point is when the sample reaches the latent head region. Generally, the temperature is constant for a time. I performed a two-factor experimental design with two replicas for each solvent. The factors were oil or crude in a volumetric proportion of solvent and crude. The first factor with 2 levels and the second with 3 levels. The proportion of each solvent were different considering the difference that exists between the cryoscopic constant of each one. I performed 4 analyses of variance for each combination, considering that the oils and the solvent are distinct. This is the behavior that was expected and that occurred in 2 cases, but other behaviors also occurred that are summarized in this diagram. In case 1, the temperature doesn't stabilize. Case 2 is a smoothing of case 1. Case 3 occurs when there are stable metaphases. The liquid cools below the melting point, and before a disturbance in the system, it suddenly freezes and the temperature shows a peak. The peak is close to the melting point. In case 4 and 5, the two-phase region passes very quickly or is present, possibly due to the change in critical points. In cases for 2, 3, 4, and 5, the melting point was when the cooling slope changed drastically. This is the summary of the melting points and of the molar mass of each combination, and graphically they look like this. Two other or typical cases were presented since they move off considerably from the trends and their respective replicas. Generally, when there are more replicas, values like these are omitted to avoid affecting the statistical analysis. The points joined by the blue line are the average of each level. With the box plot, the variation between replicas and levels seems more evident. It was observed that the combination of cyclohexane with tea oil showed the less variation, being more similar to the ideal mixture model. Considering the full analysis of variance and the rejection criteria, the null hypothesis is accepted as true in the two ANOVA that were influenced by outliers. There are the solution of cyclohexane with B and benzene with tea oil. The Kendall concordance coefficients of analysis of variance influenced by outliers are acceptable, and the intraclass correlation coefficients are high and moderate. The ANOVA without outliers get perfect and very strong concordance. Regarding the difference between replicas, 50% of all readings have difference less than 20 grams per mole, as you can see in the right side. The ANOVA assumes that the response variable is normally distributed with constant variance and that the measurements are independent. To check this, the values of the residual approximate straight line as seen in this figure, checking the normality assumed. To equality of variance, the Bland-Altman graph shows that the equality of variance isn't fulfilled due to heteroscedasticity behaviors. The funnel is being more noticeable in the benzene with T combination. For the independence, this figure presents the residuals of each measurement against the running order. There is an unclear trend. Sinusoidal behaviors could be suspected, but the independence between measures cannot be easily determined due by the low number of replicates. The molar mass of T and B may be less than 215 and 300 grams per mole. The osmometry results are too high and aren't considered representative. Setting the best method will be unreliable because first correlations are helpful to estimate, but not always they are able to predict the behavior of other data than those used for its preparation. Second, the ideal solution model is the base for CRYOSCOPY and for osmometry, something in which there is uncertainty according to the trend found in this research. However, it is possible to use a solvent concentration in which the solution has a little deviation from the ideal model. Here, the experimental results do not allow to study in high detail the deviation that the solution had with respect to the ideal model. Also, the reliability should increase in terms of concordance, reproducibility, and the real average molar mass of the oils. For the conclusion, analyzing a list of 911 solvents, 8 suitable solvents were found to determine the molar mass of crude Bycryoscopy. The laboratory test allowed to elaborate a protocol and easily accessible assembly along with some recommendation for its optimization. Also, a statistical theoretical analysis model was obtained for the results. For the study condition, the most convenient sample volume is 3 milliliters, and the most suitable concentration of solvent ratios are about 95 and 90% for cyclohexane and benzene. The osmometry results reach values significantly higher than those obtained by correlation and Bycryoscopy, while the molar masses obtained by Bycryoscopy showed similar values at different concentrations, possibly because in both methodologies the mixture didn't fit the model for ideal solutions, or the solvent concentration used were very low. The combination of cyclohexane with tea oil show less group and level variability, showing higher affinity or behavior more similar to ideal mixture model. The null hypotheses were rejected in 2 of the 4 ANOVA performed, while the other 2 analyses, the type 2 statistical error was as evidenced by the presence of outliers. The analysis of variance influenced by outliers showed about fit or inability to predict other outcomes outside of the data used for the model. Even one of these ANOVA didn't fit to the result obtained. The Kendall coefficient and interclass correlation showed very strong concordance in 2 ANOVA that were not influenced by outliers. In the other 2 analyses, the concordance were moderate and high. The planar map diagrams showed heterocyclic behavior, and 50% of the all levels present a difference less than 20 grams per mole between replicas. For recommendation, I consider that evaluate the mixture ideality through vapor pressure tests at fixed temperature and different concentration to verify the compliance with the laws of Rell and Dalton. For the assembly, use measuring instrument with precision and better resolution. For the method, choose a solvent with high critical point to better observe the latent temperature. And performing prior tests with aliquots to reduce the uncertainty of volumetric measurements. Increase the number of tests to reduce the error and get better statistical analysis and more representative molar mass values. Thanks to the teachers Guido Olaya, Jairo Sepúlveda, Carlos Valdés, Gloria Marrugo, Marina Boter, Jaime Gallego, and to the engineering model Alejandra Quintero, of course to the organizers and attendees of this event, and also to my university,